vacuum filtration, now it's almost done. All the liquid, we have the solid on the filter paper. In the Buchner funnel, I'm washing it with cold water. Just to prepare the cold water, we place the some water in the ice bath. So we wash this a couple of times with the cold water. I want to make sure my sample is pure. Often, and especially for experiment 12, I said this sample is pure, or it should be pure. We didn't do any recrystallization, so there is no need for recrystallization. In this experiment, it's the recrystallization is a key to make sure that the sample is pure, and the sample is going to give us the most accurate melting point. I normally, after the vacuum filtration, I run the vacuum for like 5 minutes for maximum water to be, or solvent rather, to be collected or removed. But because I want to do recrystallization, I don't have to continue here with the vacuum filtration. Transfer the sample to a beaker. So you normally use a spatula to transfer as much possible of the sample, and it doesn't have to be dry because water is going to be a good solvent for this product, for the is a benzoic acid. Measure about 20 milliliters of water. Add this water, could be hot water, you add, or add 20 milliliters of cold water and place it on a hot plate to dissolve. If the liquid starts boiling, if the water starts boiling and the sample is not dissolved yet, that means you need to add more solvent. So we wait until the sample is, the mixture is boiling, and if it doesn't dissolve at that point, then I would add more water. Okay, the sample is boiling, the mixture is boiling, and there are still some solid in there. I'm going to add about 5 more milliliters of the liquid, of the water, and wait until it boils again. And if all the solid dissolves, then I stop adding. It's safer to use a beaker holder to hold the hot beaker. And this sample now is completely dissolved. There is no solid pieces left in there. After heating up or boiling the sample to dissolve, we leave it on the bench top for it to go down to the temperature goes to the room temperature, or cold enough to touch, or we see that solid compound is formed, the crystals are forming. We cannot put directly from hot plate in the ice bath. Sometimes students say, oh, because it might shatter. No, it's not the material that these glasses are made, they're not going to shatter from hot to cold. But if you skip this part, the crystals are going to form right away. Precipitation would take place rather than crystallization. For crystals to form, you have to give them time. And by giving time, or slow cooling is important in crystallization. So we wait until crystals form. Now, crystals have formed here. This beaker up, or you could see the side, the crystals. Normally, I don't disturb it, but just to bring to camera for you to see that crystals have formed, I did that. So I'm going to now place the content in an ice water bath for complete precipitation or complete crystallization. The lower the temperature, lower the solubility. So it will crystallize. This is end of organic 2. You already know this, but I just have a habit of explaining things again. So 5 minutes in the ice bath, it's good enough for complete crystallization. And we normally, in the purpose of the video, we pause the video and we come back at the end of the 5 minutes. So when you have the complete crystallization, then you are going to do vacuum filtration. I don't have to measure the mass for the filtered paper this time, because for this experiment, because the purpose of this crystallization is to get pure crystals. I'm not worried about what is the percent yield. I don't even ask for percent yield. I only ask for what's the melting point, and if the melting point is going to be close and very close to one of the possible unknowns. So we are trying to do the vacuum filtration. Lots of crystals have formed, and it's a white color that shows. I turn on the vacuum, and pour the mixture over the filter paper. To transfer what is left over, I use some cold water. The solvent is water. Cold water is used for washing and for transferring. Now I want to wash the crystals with cold water. So I close the vacuum. I pour water over the crystals. For all the crystals to be like soaked in water. And then I turn on the vacuum for the water to be removed, or any washing solvent to be removed. Okay. Make sure that the vacuum system is sealed, and so there is nothing open here. The vacuum is sealed. You can wash the crystals with 2 portions of 10 to 15 milliliters of cold water. Soak the sample in water, cold water, and turn on the vacuum. We want this crystals to be dry, completely dry. So we run the vacuum for 5 minutes. And after the 5 minutes time, we come back and transfer the crystals to the watch glass. We place in the oven that is set. The solvent is 100. So if you look at the table, after you prepare the table, most of the melting point for all possible compounds is over 100. So we set the oven around 100 or 102, 103, higher than the boiling point of water to dry the sample. So when it's dry, then we measure the melting point. Okay. So it's been 5 minutes with counting the pausing video. I'm going to stop the vacuum first and break the seal here for the vacuum, transfer the sample with the filter paper or without the filter paper, as long as the watch glass is clean. That's all I am worried about. And the filter paper here, I don't need the mass of the paper. They can transfer everything into the watch glass. This is after recrystallization, and transfer or place it in the oven. So let's take this to the oven and place in the oven for 5 minutes. I don't have to video record really this, you already seen what happens. Going to place in the oven for 5 minutes and take it out to make sure the sample is dry. It has been 5 minutes since the sample was in the oven, and it looks dry. It does help to use like hot gloves or a paper towel, not to burn your hand. Just tell you that it was hot. So we transfer this to crush it. We are going to crush the crystals to make sure that it gets into the capillary tube or down in the capillary tube easier. So the sample looks dry. I just hope that the melting point also shows the same result, that the sample is dry. So we are going to take a capillary tube. We can hold from the closed end of the capillary tube. Open end of the capillary tube should stay clean. Place that, just tap a few times into the sample. The reason we don't want to touch this, we don't want to contaminate the sample. Then pass it through hollow glass tube to bring it down. For the setting, we have been using this often. The lowest melting point that you could get is like 120, 119. It could be anywhere from 120 to 250 or 260. Now, I know that it would be safe to place this setting between 4 and 5. I'm going to set it just between 4 and 5 and place the capillary tube in the sample holder and turn on the melting apparatus and wait until it melts. It might take a while before the sample melts. Okay, the initial melting right now is at 154, and I'm going to record that for you. And final melting of 156. I will send a picture. I will add the picture to the video so you could read it better. Now, completely melted. We turn off the machine every time as the sample is melted. You are using the melting point of the oxidized product to identify the sample. And you're going to write your lab report based on all evidences for the identification of the compound. And that's it for this experiment. Thank you. Transfer.